Good morning everyone. Myself Kusum Kumari from BSc MPCS. Today's our topic is transistors configuration and characteristics. What is transistors? A transistor is a type of semiconductor device that of be used to connect and insulate electric circuit or electric current or voltage. Formation of transistors. When a third doped element is added to a crystal diode in such a way that two p-n junctions are formed, the resulting device is known as transistors. A transistor may be regarded as a combination of two diodes connected back to back. Parts of transistors. There are three terminals for a transistor: base, collector, emitter. Base. This is used to activate the transistor. Collector. This is the positive leads of the transistor. Emitter. It is a negative lead of the transistor. Here we can see the transistors of the diagram. Next, there are two types of transistors: unipolar transistor, bipolar transistor. What is unipolar transistors? The definition of the unipolar transistor is a type of transistors in which electric current flow due to the only one type of changes, either holes or electrons. Examples of the unipolar transistors is GFET, MOSFET. The diagram of the unipolar transistor is this. Next is a bipolar transistor. Bipolar transistor is a semiconductor device in which electric current flow due to the electron and holes both simultaneously. There are two types of bipolar transistors: NPN and PNP transistors. We can see the bipolar transistor diagram here. Next, in that bipolar transistors, we learn about the NPN transistors. The NPN transistors consists of two N-type semiconductors separated by a thin section of P-type semiconductor is known as a structure of the NPN transistor. In case of the electric current flows from base to emitter. It flows from the base to emitter. Here we can see the clearly picture of the NPN transistor. Next, what is the working principle of the NPN transistor? The current circuit diagram of the NPN transistor is shown in the figure. You can see here the diagram of the NPN transistors. The forward bias base is applied across the emitter base junction and the reversed bias is applied across the collector base junction. The forward base voltage is VEB, we denoted as VBE, is smaller is compared as the reverse bias is a VCB. The emitter of the NPN transistor is heavily doped. When the forward bias is applied across the emitter, the majority charge carriers move forward the base that causes the emitter current IE. The electrons enter into the p-type material and combine with the holes. The base of the NPN transistor is slightly doped, due to which only few electrons are combined and remaining consists the base current is IB. This base current enters into the collector region. The reversed bias potential of the collector region applies the high attractive force on the electron reaching collector junction, thus attract or collect the electrons at the collector. The whole of the emitter current is enter into the base. Thus we can say that emitter current is the sum of the collector of the base current. IE is equals to IC plus IB. Next is PNP transistor. We learn about the NPN transistors. Now is PNP transistors. A PNP transistor is composed of two type semiconductors separated by this thin section of the n-type is known as structures of the NPN transistor. In the case of the electric current flows from emitter to the base. Here we can see the PNP diagram working of the PNP transistor. The emitter base junction is connected in forward biased, due to which the emitter pushes the holes into the in the base region. These holes consist the emitter current. When these electrons move into the n-type semiconductor material or base, they combine with the electrons. The base of the transistors is thin and very lightly doped. Hence, only a few holes combined with the electrons and the remaining are moved towards the collector space charge layer. Hence, develops the base current. It develops the base current. The collector base region is connected in reverse biased. The holes which collect around the depletion. This develops the collector current. The complete emitter current flow through the collector current IC. IE is equals to IC plus IB. Next, configuration of the transistors. There are three types of configurations are in the transistors. Common emitter transistor, common base transistors, common electro transistors. Learn about common emitter configuration. The configuration in which the emitter is connected between the collector and the base is known as a common emitter configuration, which connected between the collector and base. Collector and base which is connected is called as a common emitter configuration. Next is common base configuration, CBC. In CBC configuration, the base terminal of the transistors will be connected common between the output and the input. In here we can see common between output and the input. Next, common collector configuration, CCC. In CCC configuration, the collector terminal of the transistor will be connected between the output and the input terminals. Here we can see the diagram of the CCC. Thank you for watching.